in Chapter 11, we're going to be discussing more about our object-oriented programming concepts. So quite a bit of theory and quite a bit of terminology that we have to learn. Some terminology which we're going to be covering in this chapter is constructors, what these methods are, and how do we construct objects with these methods. Destructors, opposite of constructor, how do we destroy our objects. We've got composition, how our objects are composed of, our class is composed of. We've got inheritance, inheriting attributes and methods from other classes that are more of a superclass or a parent class in our child classes. We're going to be chatting a bit about our graphic user interface objects and how we create them for our users. We're also going to be discussing some exception handling, which helps make sure our programs run smoothly without any data errors, etc., or data entry errors. We're also going to be discussing the advantages of object-oriented programming, some more advantages. But first things first, constructors. If you recall, we learned that we create classes to encapsulate data and methods, right? We also learned that you can instantiate objects from classes that you define, such as the employee class, and then you instantiated objects like my assistant. Now, when you instantiate an object, such as employee, like I said, but let's create an employee object called chauffeur. So our chauffeur is an object. So when we create an object like so chauffeur, we create a box of memory that's going to hold all the attributes that describe our employee and describe our object as chauffeur. So we're going to be storing all those field variables within our box of memory, and we're going to call this chauffeur will be the label on my box. All right. So our employee here is my class name, and my chauffeur is my object identifier. Okay, so we call it our object identifier because we're identifying our object, like identifying our box, like a label, for instance. So what you're actually doing when you're creating an object, you are actually calling on a method called employee, and this employee method allows you to construct an object called chauffeur. This method is the same name as the class, and as I said, it establishes an object. So it's when I talk about constructors like this employee constructor here, I'm talking about a builder that builds objects, builds a box of memory. All right. So in short, a constructor is a method that has the same name as the class, and it establishes an object. Now, a default constructor. This default constructor requires no arguments, like your employee. All right. What's so great about the employee constructor without any arguments, what I mean by arguments, I mean by nothing within the brackets, it is created automatically by the compiler for every class you write. So you don't really need to have it in your class that you defined. If you recall on the employee class that we defined early on, we did not write any of this, but we could still instantiate objects, right? Now, a non-default constructor. Well, a non-default constructor, if a default constructor's doesn't have arguments, a non-default constructor requires arguments. So it requires something for you to put in the brackets. So in this case, maybe I can give my hourly rate in the brackets here. So it requires an argument from our application class or from our object, which we instantiate. So in short, our default constructor for our employee class establishes one employee object with the identifier provided. So when we declare constructors, we declare them to be public so that other classes can actually instantiate objects that belong to that class. So if it's private, you can't really create any objects. You can't create boxes of memory. So we write any statement you want in a constructor. what's quite nice is that you can place the constructor anywhere inside the class. It doesn't necessarily need to be at the beginning of the class, but often programmers list these constructors first. Let's have a look at 11.1 over here. What we have is a default constructor here that we have created, and what we are actually doing is the employee object will have a starting hourly wage of $10 and a correct weekly page for that. So when you call on the calculate weekly pay method within the constructor, remember our calculate weekly pay method over here is private. So when we're calling that within the constructor, it's quite nice is because now calculate weekly pay, you're giving a correct wage automatically using that hourly wage which you have, which is $10. You can write anything you want in a constructor. It is just a method. So you can even write an output message within our constructor. You can declare local variables within our default constructor here. You can also declare accept input in our default constructor here. Depending on programming language, the automatically provided default constructor here might provide initial values for the object's data fields. So what you must remember is that in many programming languages, all numeric fields, so all our numeric fields are all set to 0 within our default constructor for you. You can see here that we have no void over here because we do not return nothing, but we are creating objects here. So you could basically say that what we are returning is we're returning a little box of memory for our object to be created in. So you can see it as such. There is no return type here either because we are returning a box of memory. Now 11.2 over here is our application. How do you know it's an application? We've got start and stop. It's showing a program which two employee objects, my personal trainer and my interior decorator, is declared and their hourly wage values are displayed straight away. So when we are calling on the employee and creating an object, we're actually calling on our employee class here. In figure 11.3 here, you can see that the set hourly wage method is never called directly in the program. Can you see that? We've never called set hourly wage in our program. Why? Because the employees possess a valid hourly wage set by their constructors, which is $10. In 11.4 over here, we have a potential superior way to actually write the employee class constructor. We have a named constant, which is our default hourly wage. Why do we like our named constants? Is because they kind of bounce at you saying that this is a value that does not change within our program. And we call on our set hourly wage straight away when we create an employee object like personal trainer, like my interior decorator. You might ask, what is the advantages of this technique? Well, the statement to call calculate weekly pay is no longer required in your constructor over here. Since we are actually just calling straight the set hourly wage method, and this calls the calculate weekly pay method straight away. Okay, can you see that? So our set hourly wage or calculate our weekly pay is called on our set hourly wage, so we don't need to have this in our constructor. That's why I say this is more of a superior way to actually write our employee constructor, class instructor. So in future, if restrictions should be imposed on our hourly wage, code only needs to be altered in one location. And if we alter in one location, that means we have a reduction in our workload and reduction in possible errors as well. So of course it's different. Hourly wage requirements are needed at initialization than are required when the value is actually set after the constructor. So we're going to have different code statements in the constructor than those written in our set hourly wage method. To answer that question, that if we have a different hourly wage, well, that brings us to our non-default constructors. So now we've got now a different hourly wage. So we're going to have a non-default constructor. So something that you are going to have to create, something with that actually accepts parameters. So when you are actually creating your own constructors, your default automatically supplied no longer accessible, because now you have a default constructor. So when you're going to choose to create an employee objects with values that differ from each employee, you've got to initialize each employee with a unique hourly wage straight away when you create yourself an instance of your employee class. You're going to write your constructors that receive arguments, such as employee, part-time worker. Part-time worker would be your instance of your employee class, so it's your object. And you can see here is our hourly wage, which we directly going to have to input. So it's a unique hourly wage which we are inputting when we use on an employee non-default constructor that has the same as the class name. So it will be the same as your class name, but it requires an argument to be passed. Employee part-time worker, so the value is going to be entered by the user in your application class. So when the constructor executes, your numeric value within your constructor is called, and it's passed to your employee default constructor or non-default constructor in your employee class that you have defined. So if you have a look at figure 11.5, this shows an employee object that receives an argument, and the num rate here takes on a value of our argument. Our hourly wage here, which is a rate, so whatever is within my argument that is being passed from my instantiated object that I've created in my application class, that is going to be stored within our field variable within our construct method. So if a class's only constructor requires an argument, you must provide an argument for every object of that class you create. So once you write a constructor for a class, you no longer receive an automatically written default constructor. So you're going to have to, whenever you create an object, such as our part-time worker will be 8.11. Let's say you declare another object called chauffeur. Chauffeur is also going to have to have a numeric value within its parameters when you want to create chauffeur object. But what if you're still going to have some employees that are still going to have the hourly wage of $10? You still want to be able to have this constructor method that has been automatically assigned. So the new version with a parameter like this one, you just want to be this as a new version, but you still want to be able to use your old version of your default constructor that had nothing within its arguments. This is where we come to our overloading methods and constructors. If you recall in chapter 9, we overloaded methods by writing multiple versions of the method with the same name but had different arguments. When I talk about different arguments, I mean different things happening within their brackets. These instance methods and constructors can be overloaded. So you can provide as many versions as you want to your constructors, whether you got your standard default constructor with nothing within its arguments, but then you can have multiple different non-default constructors that receive various different types of values through their arguments. So let's have a look. What is an overloaded method? You're just writing multiple versions of that method. Any method or constructor in a class can be overloaded, and you can provide as many versions as you want. So here is an example. We have our normal default constructor here that sets our hourly wage to $10, and then we have our overloaded method or our overloaded constructor here that receives an argument of rate from the outside world. So if you recall, the method's signature is its name and the list of argument types. So here would be my method name would be employee, which will be my constructor, and its list of argument types will be nothing within the parameters. Here we'll have to have rate within its arguments. So the constructors in 11.6 have different signatures. Can you see that? No argument for the default and requires numeric argument for the non-default. If you use the version of a class in figure 11.6, then you can you can actually make statements like employee, delivery person with nothing within its brackets, or employee my butler, who will require an argument of 25.85. So the hourly wage is set to be passed. So this value is going to be passed into rate, and that rate is going to be stored into hourly wage. Remember, you can create as many versions as you want, as long as each version has a unique signature. So whatever happens within these brackets, it's got to be unique. So if you have a look at figure 11.7, this is the third possible employee class constructor which you can create, a non-default constructor. Here we accept rate in its argument as well as string name in its argument. So creating many versions creates flexibility for your client programs.